So now let's continue our explanation of the filter experiment. Okay, so let's suppose that we've got a filter, and so the orientations of the filters don't have to be perfectly vertical or horizontal either. Okay. And so I'll call that F, and so that'll be, could be some combination of vertical and horizontal with coefficients C and D, respectively. And then for the photon, we were calling that X last time, so we can just stick with that. All right, so the idea then will be that the photon passes through the filter. Okay, and again, so this is sort of a non-deterministic process. Okay, so there's a probability that this happens. So with probability, so given by the dot product of f and x, magnitude of that squared. Okay. All right. And so again, remember these are written as linear combinations of these basis vectors, right? But I can also really just write them as vectors if I want. Right? So this could be the vector CD in two-dimensional complex space. This could be the vector AB. Okay, and so then the dot product of f with x would be this dot product. Okay. And if these were just real numbers, right, then this would just be CA plus DB. But since these are complex, then we actually have to conjugate those first components. Okay, so C conjugate A, D conjugate B. Okay. All right, so if we go back to our three filter experiment then, look what happens. Okay, so what are my filters? Okay, so F1 is just V. Okay, so F2, so it looks like it's at a 45-degree angle, right? So it should be have equal components in the V and H directions, but it would also be a unit vector. Okay, so this should be 1 over root 2 V plus 1 over root 2 H. Okay, so that's F2. Didn't leave myself a lot of room here, but this would be F3 then, which would just be H. Okay. All right, and so let's suppose then initially my photon just to make the calculations a little bit easier on ourselves, let's suppose it has initial polarization V. Okay. And remember that with the two filters, no matter what the initial polarization was, it was going to get blocked. Okay. All right, so then photon is going to pass through the filter F1 with certainty, right, with probability equal to 1. So since my polarization, I can think of it as 1, 0, right? F1 is also 1, 0, and so the dot product is just 1. Okay, and so the dot product squared is 1 squared, which is still equal to 1. Okay. All right, that agrees with what we said last time. All right, so we just we give formulas for calculating probabilities, but they agree with the sort of qualitative version that we did last time. Okay. All right. So now, well, the polarization is still vertical. Okay. And it's still 1, 0. Okay. So now we're at filter F2. Again, so let me just write that as a vector. So we can maybe compute dot products in a way we're a little more comfortable with. Okay. And so then, what is the magnitude of that dot product squared? Okay, well that dot product is just 1 over root 2. So it's going to be 1 over root 2 squared, or 1/2. Okay. All right, so once a photon gets through the filter F1, right, it's going to be vertically polarized, and there's going to be a 1/2 probability that it gets through filter F2. Okay, all right, but again, once something gets through a filter, then it's polarized in that direction. Okay, so now in our third step, assuming it makes it through, so x is 1 over root 2, 1 over root 2, F3. Okay, so that's purely horizontal. So that's going to be 0, 1. And so the probability it passes through the third filter is going to be the magnitude of that dot product squared. That dot product is still 1 over root 2, so 1 over root 2 squared. Okay. And so that'll be 1/2. Okay. All right. And so these are independent events. So a photon that is already polarized to get through filter F1 has a 1/4 probability that it makes it to the screen. Okay, so light can still get through, but the intensity of the light will be much diminished. Okay. All right, so this gives an explanation of this experiment, and so really, it's this sort of interesting quantum mechanical phenomenon. It's nice to see an explanation of it. A couple things to take away. So maybe the explanation is a little bit mundane, a little bit of a letdown from this sort of paradoxical looking phenomenon. But one thing to note is that an interesting thing is that what's going on here is it's non-deterministic, right? So if you have any particular photon, you can't say with any certainty, right, whether that photon will get through or not, right? Unless it was horizontally polarized at the beginning, it would certainly be blocked by the first filter. Okay, but sort of stochastically in the aggregate, so 1/4 of those vertically oriented photons will be getting through. So there's a sort of probabilistic underpinning to the mechanics of what's going on here. Second, so the fact that if we're talking about describing a single particle, so the state of that particle, right, can kind of exist as the superposition. So we really need vectors, right, in this two-dimensional space to describe the state of a particle, rather than just being able to get away with these single bits, the ones or zeros. Okay. All right. So then next time we'll kind of use this as a motivation for what's known as a qubit. And so that'll be sort of the fundamental units that's going to be used to store quantum information.